Hi, I'm Guang, 15 years old, secondary 3 friends, high school. In this lesson, we're having the techniques and applications of limit calculation. So for previous few lessons, we have learned a few techniques which you can use, namely gamma function, and of course some applications of where you can use the gamma function. But in this lesson, we will be taking a look at two more of these examples to see how exactly we can use gamma function, alright? So starting with the first example, you'll see 1 minus 1 over 2 square multiplied by 1 minus 1 over 3 square multiplied by 1 minus 1 over 4 square, and so on. So of course, if you don't know how this works, you can change it into a limit form, which you have, let's say, limit n approaches to infinity, and the last term will just be 1 minus 1 over n squared, alright? But of course, if you already know that, then you can probably just skip that. So just in case you don't know, it is basically the same as this part over here. So even if the question doesn't have a limit, it might still be a limit question. Alright, so this question, how do we plan on solving it? Now, we could change it into a pi notation first. So you can have pi notation n starting from 2 until infinity, and you have 1 minus 1 over n squared. Alright, so you can change it to this form. Now, what kind of methods have we used previously? We have used things like Wallace product. How about let's try to change this into that form. So you will have pi notation n from 2 to infinity, n square minus 1 over n square. So this can be n minus 1 times n plus 1, but n starts from 2. But in order to use your Wallace products, you have to make this n starting from 0. So n starting from 0, so pi notation n from 0 until infinity, then you're going to have to change to every one of these n into n plus 2. So in the numerator, n plus 2 squared is n squared plus 4n plus 4 minus 1 plus 3. Then you divide it by n plus 2 squared. Alright, so in the numerator, then you can factorize. And you will get n plus 1 multiplied by n plus 3 divided by n plus 2 squared. So does this satisfy the conditions to use the Wallace product? You have n starting from 0 until infinity. 1 plus 3 is equal to 2 plus 2. Alright, so now we can use our Wallace product. That means you have gamma 2 multiplied by gamma 2 divided by gamma 1, gamma 3. So this you have 1 times 1 over 1 times 2. That means your answer here is half. Alright, so this is your first example. But there are some cases, like let's say whatever you get here, maybe you don't want to factorize it. So if you're up for a challenge or you just don't want to use that method, there are also other ways, like let's say you take every alternative term. Well, of course you can also take terms in multiples of 3 and all, but that will be completely up to you whether you want to try to solve a larger portion of these expressions or not. Alright, but there are many different ways to solve a single question. Alright, so that will be for your first example. Now we take a look at the second example. We have 3 over 2 multiplied by 3 over 4 times 6 over 5 times 6 over 7 times 9 over 8 times 9 over 10. First of all, you want to try to find the pattern. First, the pattern in the numerator. They're all consecutive multiples of 3. then the denominator, it will be 1 is you deduct by 1, the other is you add 1. Then same thing, the first term you have minus 1, then plus 1, and so on. Okay, so that's the first step completed, the pattern. Now when you know this pattern, you can express it into your pi notation. Of course, you can also change it into a limit notation, but it's really up to you. So pi notation, then let's say our n starts from 1 and ends at infinity. So if n starts from 1, your numerator, you're going to have 3n squared. Or in denominator, you have 3n minus 1 multiplied by 3n plus 1. Alright, so this is what you are going to see if you write it into a pi notation. Now, n is equal to 1. Let's change that into an n is equal to 0, alright? So, n is equal to 0 to infinity with the pi notation. Then you're going to have 3n plus 3 squared over 3n plus 2 multiplied by 3n plus 4. So this is what you are going to have. Now, do you have all the conditions fulfilled? Wait, there's these 3's in front of the n's. So let's divide both numerator and denominator by 9, since it is 3 squared. So when you divide each of them by 9, what will you see? N plus 1 square divided by n plus 2 over 3 n plus 4 over 3. Right, now does it fulfill the conditions to use your Wallace product? Let's take a look. It starts from 0 to infinity, that's right. Each coefficient in front of n are all 1, alright. 1 plus 1 is equal to 2 over 3 plus 4 over 3, since both of them will add up to 2. Alright, now we can use our Wallace product. So we are going to see gamma 2 over 3 multiplied by gamma 4 over 3 divided by gamma 1, gamma 1. Right, so we know what gamma 1 are. They're both 1. But what is this numerator? Now this numerator, 2 over 3, well, I don't think we can find that by itself. 4 over 3, I don't think we can find that by itself either. But beware, the key thing is by itself. So maybe if you combine it with some other things, then you'll be able to solve it. Now, if you can recall what we used in the last lesson, well, we had your gamma, let's say x, and gamma 1 minus x. Well, x is bigger than 0, smaller than 1. So this will give you pi over sine x pi. Alright, so we use this formula, which you can also call it the Euler's reflection formula. So, but these two, you realize they add up to 1. Does these two add up to 1? No. 2 over 3 plus 4 over 3 is 2. So how do we solve it? That means we have to use something else. Or not completely something else, making use of something else. Gamma, let's say a. This will be a minus 1, gamma a minus 1. We have to use this formula. So using this, we can change gamma 4 over 3 into 1 over 3. So your gamma 2 over 3 stays, well, gamma 4 over 3 becomes gamma 1 over 3 with this 1 over 3 in front. So now these two add up to 1, where we can now use our Euler's reflection formula. Now Euler's reflection formula, so you have pi over sine pi over 3. So what is sine pi over 3? square root of 3 over 2. Now, you can leave this in a form of two pi over 3 square root of 3, but generally we would prefer making the denominator not a root. So you can technically leave it in either of these forms, but we generally like this form below. Alright? So these are the two examples in this lesson. Now, is there anything so special about them other than the fact that since they don't actually use your limit notation, but they are just limit questions? So another thing, do you find a difference between these two questions? Seem pretty similar, right? Or in the last lesson, what you realize is multiple or infinite rational numbers, for both of the questions in the previous lessons, they become irrational numbers. But in this lesson, you take a look at the first question. You have infinite number of rational numbers multiplied together, and you get a rational number. But in the second example, although you have infinite rational numbers multiplied together, you get an irrational number. So those are some of the very interesting things that you can find with these different questions, but I hope that you can understand them so far. Now the important formulas, your Wallace product, your Euler's refraction formula, and of course some basic formula for gamma. Well, this is also kind of how you can say gamma A would just be A minus 1 factorial. Alright? So that will be pretty much it that we have for this lesson. I hope that everything is clear so far, and thank you for your watching.